All right, peeps. Today we're talking about actually two different things. Technically three different things, but two of them go together, so I kind of count that as one thing. The first thing we're talking about is prime numbers and composite numbers. And then after that, we're going to use those prime numbers and composite numbers to talk about prime factorization, which is really just breaking numbers down. You will need your division and multiplication skills pretty good for this assignment. If you know how to make multiples of things, though, just knowing how to multiply should be fine. But if you are good with your division skills, you can find the multiples for any number just by dividing it by a certain thing and taking those two multiples. Prime numbers. So prime numbers, first of you guys, it is a weird list of numbers. It's not every odd number. It's not every even number. When you're dealing with a prime number is a number that only has two factors. So I'm going to give you guys a couple examples of prime numbers and kind of explain it, and then I'm going to give you guys the full list of them. An example of a prime number would be 3. And what I mean by it only has two factors is there's only two numbers you can multiply to make 3. 1 and 3. 2 times nothing makes 3. 3 times 1 makes 3. That's what we already have there. So the only two factors 3 has are 1 and the same number. So 3 would be a prime number. Another prime number would be 2. The only way to make 2 using multiplication is 1 times 2 or 2 times 1, but that's the same thing, just flip-flopped. Prime numbers only have 2 factors. A couple more examples before I give you guys the list. Even larger numbers like 11 can be a prime number. You can't do 2 times a whole number to make 11, 3, 4, 5. None of those numbers are multiples of 11 except for 1 and 11. Before I do the list of prime numbers, I'm going to tell you guys some things about composite numbers. Composite numbers are similar in definition to prime numbers, except composite numbers have more than 2 factors. So I'm sure you guys can think of a bunch of numbers that have more than 2 factors. Let's start with some smaller ones, though, like 4. Ways to make 4. Yeah, you could still do 1 times 4. But you could also say 2 times 2. So 2, 1, and 4 are factors of 4, which means it has 3 factors. That's why it's composite. Let's try a little bit of a higher number. What if I said 20? Most of you guys are probably thinking, yeah, 20 has a lot of factors, right? 20 could be made by 5 times 4, 2 times 10, and 1 times 20. So 1, 2, 3, 4, 5, 6 different numbers are factors for 20. That's why it's composite. Composite numbers, actually some odd numbers are composite as well. Prime numbers, the only even prime number is 2. But composite, you could have a lot of different odd numbers that are composite. You have to see if it can be divided by multiple things, or what I'm saying is if it has multiple factors. An example would be 15. Obviously, yes, 1 times 15. But there's also 2 other factors that go into 15. 3 and 5. So since all of these numbers over here in the pink have more than 2 factors, that is what makes them composite. Since these numbers in the blue only have 2 factors, that makes them prime. So y'all, I'm going to erase this. If you need to write some of those down, you can write them real quick. I'm going to actually give you guys a short little list of some of the prime numbers. This is not all of them by any means, y'all. Prime numbers continue for forever or for infinity. The prime numbers you'll need are 2, 3, 5, 7. 9 is not a prime number because 9 can actually a factor of 9 is actually 3, 1, and 9. So we're not 9. 11, 13, 17, 19, 23, 26, 27, 28, 29, and 31. I'm not going to give you guys a bunch more than that right now, y'all. That's all we should be really. That's all we're really going to talk about here today. Composite numbers, I'll give you some of those as well. So, y'all, if these are all the prime numbers, the composite numbers are the ones that are in between those. 4, 5, 6, 7, 8, 9, 10, 12, 14, 15, 16, 18, 20, 21, 22, 24, 25. I'll do a couple more. 26, 27, 28, 30, and 32. So yeah, just from those lists, you see I stopped about the same number, 32 and 31, but hopefully you see that composite numbers make up a lot more numbers than prime numbers. A lot more numbers, especially as you start getting higher up in numbers, there's going to be a lot more numbers that can be divided by things, y'all. So you're going to, composite numbers continue for infinity as well, just like the prime numbers do, but you are always going to have more composite numbers. So the reason these two things are important, and I definitely want you guys to write down all these prime numbers if you're working online, because you're going to need these for the actual activity today when we talk about prime factorization. I'm going to pause because I'm going to move over there on the screen. But like I said, write that if you need them. All right, y'all. When you're using prime factorization, what you're really doing is taking a number that they give you, and you're going to keep breaking it down into factors until all of the numbers at the bottom are prime numbers. And remember our prime numbers from the side over there? I'm going to write a few of them on the side right here, just because we're going to need them again. 2, 3, 5, 7, 11, 13. I think that should be enough for us for right now. So first thing I'm going to look at is the number 80. I need to know two numbers that multiply to make the number 80. There are a lot of numbers that multiply, but the cool thing about these is whatever you use, as long as they're the right multiples, you'll always get the right answer at the end. So some people are probably thinking, oh, well, that's 8 times 10. You are right. 4 times 20. You are right. 40 times 2. You are right as well. I'm going to start with 8 times 10 because I like when my numbers are closer to each other because then it makes my math a little bit easier. So 8 times 10 makes 80. The only time you can stop on a prime factorization tree is when your numbers at the very bottom of each side are all prime numbers. When your numbers at the bottom are prime, you can circle them and stop moving. Or stop breaking it down, excuse me. My next number, I'm going to break down 8 because 8 is composite and 10 is also composite, so that means they both have factors I can use. You can never use 1, y'all, because if you use 1, you're going to get the same values again. If I did 10 and 1, I would have 10 again. If I did 10 and 1 from there, I'd have 10 again, and it would never end. So you can never use the multiple times 1. Ways to make 8. 4 times 2 make 8. 2 is one of my prime numbers, so I can actually stop and circle that. I don't have to break down the 2 anymore. But I can still break down 4. Ways to make 4. 2 times 2. 2 is prime number, so I can circle these both. And I'm done. On the other side, I still have a 10 to break down. How can I make 10? 2 times 5 makes 10. Look at my list here. 2 is a prime number, so I'm going to circle it. 5 is also a prime number, So I'm going to circle that as well. Once everything at the bottom is circled, you actually have your answer. So here at the bottom, I have 2, 2, 2, 2, and 5. I like to write mine in order. So since these are 2s are the lowest number, 2 times 2 times 2 times 2 times 5 is my answer. There is a way to write that in what we call exponential form. We kind of talked about that a little bit these last couple of days when we were talking about exponent numbers. Since I have 1, 2, 3, 4 2s, I can actually write 2 to the 4th power, and then since there's only one 5, times 5. Either of those answers are acceptable. Both of them are correct. Yeah, I'll take either one of those answers whenever we do the assignments. You people online will not have an assignment really for this today. Tomorrow I'll have something a little bit different set up for you guys, so you guys can like send me some pictures of your work. Really today, as long as you're watching the video, you should be fine on the stuff tomorrow. Let's try one more of these. I know this video is getting a little bit long, guys, but thank you for watching. So we're going to try one more number on here. I'm going to use the number, let's say 64. There's definitely a lot of ways to make 64, but I like 8 times 8. Those aren't prime numbers, so I'm going to break them down again. Things that make 8 are 2 and 4. 2 is a prime number, so I can circle it. 4 I can break down again to 2 times 2. Sorry. Both of those are prime numbers, so I can circle them. I'm not done though, because I still have to break down this 8. There's nothing circled on that side. 8 is 2 times 4. Circle my 2. 4 is 2 times 2. So for this problem, my answer, since everything at the bottom is circled now, 2, 2, 2, 2, 2, 2, that's 6 2s. 2 times 2 times 2 times 2 times 2 times 2. Or, since we're talking about an exponent, 1, 2, 3, 4, 5, 6, 2 to the 6th power. Y'all, if you have any questions, I know that this stuff is kind of a lot to understand at this point. But if you have any questions, please let me know. Send me a message, send me an email, or you can join Zoom during class so we can talk about it. Thanks, guys.